Okay, now we're ready to subtract rational expressions that contain polynomials. Remember, a polynomial is a sum of many monomials. So if we have a subtraction symbol in front of a polynomial, whether it has 2 terms, 3 terms, or 4 terms, that subtraction symbol means I'm subtracting all those terms behind it, which means all those terms have to become the additive inverse. Okay, if you look at the PowerPoint, here's an example we've done way long time ago. I have the binomials 4x plus 5, and I want to subtract 3x minus 2. So first of all, we know we can't subtract because we're stuck in parentheses. So in front of our first set of parentheses, 4x plus 5, there's an invisible 1. So that means 1 times 4x plus 5 would be 4x plus 5. In front of our other set of parentheses, 3x minus 2, there's a negative sign, which means subtracting. And subtract means to rewrite as adding the opposite. So we would change that subtraction symbol to addition, and then we would change all the terms behind it to their opposites, their additive inverse. Because there are 2 terms behind that subtraction symbol, the 3x and the negative 2, we change both. So the 3x would become negative and the 2 would become positive. And then once we rewrite this as addition, we could collect our like terms. The same thing's true when we're dealing with rational expressions. We're going to change subtraction of fractions into addition. And we have to understand it in that second numerator. If there's a binomial 2 terms, or a trinomial 3 terms, or a polynomial 4 more terms, we change all of the terms to the opposite, the additive inverse, not just the first one. So let's look at our example. We have 2x squared minus 7 over x minus 2. Subtract x squared minus 3 over x minus 2. Clearly, we have 2 fractions connected by subtraction. So the first rule is there is no such thing as subtracting. You're going to add the opposite. So we're going to change that subtraction symbol in the middle to addition. We're going to make the opposite the fraction behind the subtraction symbol. So we're going to take that numerator and change it, make it the additive inverse. So what is the additive inverse of x squared minus 3? It would be negative x squared plus 3. The mistake you guys all make is you take that negative sign that's in the middle of the fractions and you float it up and only put it with the first term, x squared. So you'll make the x squared negative, but you'll forget to make the negative 3 the opposite. And that's what you got to make sure of. You're adding the opposite of the numerator. So if there's 2 terms in the numerator, you have to change both. Now that it's rewritten as addition, we can sing our song. Adding fractions easy as can be, all we need is an LCD. All right, the first denominator is x minus 2. The second denominator is x minus 2. They're alike. Great. We write the denominator, x minus 2. We're going to collect the numerator. So we have 2x squared minus 7 plus a negative x squared plus 3. We have 4 terms now in the numerator. Are all 4 alike? No. Let's find the terms that are alike. So we'll take our 2x squared and subtract our x squared, and we'll get 1x squared. We'll take our negative 7 and put it together with our positive 3, and that will give me negative 4. So now I have in the numerator x squared minus 4 over my denominator x minus 2. So now I've done my job. I've made 1 fraction. But remember, the bar means to do division. And you cannot do division just yet because you're not connected by multiplication. So here's where that light goes off. I need to factor. How do we factor x squared minus 4? Well, that's a difference of perfect squares. So I put my 2 parentheses, I put my x plus 2, and my conjugate x minus 2. Now if I look, now that I'm connected by multiplication, I have like terms. I have the same term in the numerator and the same term in the denominator. I have x minus 2 and x minus 2, so they will divide out and make 1. So 1 times x plus 2 is x plus 2. The moral of the story is real simple. Subtraction gets changed to addition, and if that numerator has more than 1 term, make sure you change all the signs so that way you're going to get the correct result. You have to make the second fraction, that numerator, the additive inverse. All right, let's try another example on the whiteboard.